Hello. Hopefully this recording turns out good. OBS just gave me like a little bit like an angry thing that was saying that my encoding was overloaded. So that sounds really scary. Anyway, I just wanted to start off by saying how grateful I am for all the comments and all the views and the likes on my last video. I wasn't really expecting anybody to see it. Because I don't really share any of these projects with anybody, so that was really cool. So thank you. Anyway, I worked a bunch in the past week. Like 2 days were spent on the map editor, and then the rest of the week was spent in pain working on the collision. But I got it to an okay point currently. So I guess the real flashy thing is going to be showing off the map editor, which is pretty cool, right? So we can do the light, which is cool, and this is corner selection for the current whatever we're editing terrain-wise. So this is going to interpolate that corner. This does that corner. All that good stuff. We can do this, we can do this, we can do this. This is just control, add stuff to the current selection. And you can do that. So the reason why these don't get these surfaces in real time is just I haven't written the routine, and it's better for debugging, just collision wise, to have those generated separately for now. So all the slope interpolation works fantastic. Like walking up slopes works perfectly, very smooth, very good. The issue is mainly with these collision surfaces that we're going to get into, and in the future with making those surfaces extendable for different elevation in the future. So I did find this bug where if you go here, the fog gets taken away. So this is kind of cool. This is what it looks like without the fog. I think it looks kind of cool. So there's that. What else? I can show off the that you can take away walls on map reload. So let's reload really quick. Yeah, it takes longer to reload when I'm recording. So yeah, that takes away this wall, and then as you can see, the light map regenerates and changes. And we can change floor texture. We can change the ceiling. We can change the skybox. We can change walls textures to whatever. Oh yeah, something funny here. So this will actually take this away. And the reason why is because, so when you, this is actually not even like a bug per se. This is just kind of like this is actually intended behavior, is like, so this wall gets put in here. As you can see, this little wall that's now inside of this square that's actually this wall that got moved over. The reason why is because they have the same start index. So as you can see, these surfaces now generated. The issue why these are currently bugging out like that is actually purely just an issue with my logic on generating them, because once you have two surfaces that are already up against each other and a certain corner interpolation, they will make an extra texture that then gets buggy. I think it's this triangle is supposed to not exist. Yeah, as you can see, this isn't needed because you already have this surface, so it does like an extra one. So yeah, I have to figure out how to fix that. because that should just be like that. But that's purely a logical issue. So all the collision seems to work fine, but it actually doesn't. And I'll make some specific examples of when it doesn't, like here. there's some bugs with it, and so yeah, I got really frustrated with it, and so I ended up taking a break. So this is actually just the wall, the ceiling texture. So you can change all the textures, and then you can add entities like this. This just added one, but it's below the floor because it adds it at the exact Z that I click on. So you choose size, all this good stuff. Let me get back to that one. Then change the brightness. And then let me change the light. Let's just make it a white light just to show off. And then reload. So all this map editor stuff was actually really easy to implement. It's not a big deal. The collision stuff is what's going to be a problem. So now you can see that there's this this white light here, super simple. So my goal with slopes and collision is to get it all this smooth, you know, just like perfectly smooth. The issue with getting it that smooth is that it's hard to do collision when you're working with exact values like that. So that light is like really bright. Let me get out of entity placement mode. So that's pretty much all of the map editor features, I think. So yeah, for some reason I have this bug where when you exit entity placement mode, it doesn't give you your selection back really at the same time when it should have. So let me make this surface specifically for the purpose of showing you some of the collision stuff. Okay, so there's that surface over there. Let me turn that ambient light up so that YouTube artifacting doesn't make everything sucky. And then let me reload to talk about it. Okay. So that's what this video is mainly going to be about, is me walking through the collision code and talking about why collision is so difficult in video games. And I was not really prepared for it at all, but this is actually gone. I fixed this, but yeah, so this little bump here, it's actually a big issue. Kind of the root of all the collision issues that will exist into the future is this one bump here. And we'll talk about why, but yeah, so this is super smooth now. This took a long time to figure out. So if you think about it, the player radius is just a circle around the player that we check, right? So that you don't see through walls and you get stuck here, right? So the issue with player radius is now when you come up here and then you hit the wall from this side, how do we determine which is the wall that faces outward versus which is the part of the wall that faces inwards? Well, there's a normal, right? It took me a while, kind of embarrassingly long, to figure out how to do all of that, but I guess I can switch to the code now. We can talk about that for a little bit. So, okay, where is the function? Where is the function? Be in check collision, be in here. This is the function. So we calculate the normal, and then we come down here, and then we say if the normal is greater than 0, we are going to say if the player y is less than or equal to the plane y. The plane y is that exact flattened value that the wall is at, either on y or x, depending on orientation, then we are going to return false, which means that we aren't going to sample it yet because we aren't past it, right? And so if the player is greater than the plane, then we are going to return true, and then we should sample it. The reason why this is called should sample versus like check if collision is because our collision surfaces aren't actually only collision surfaces. They are floors. That was a big problem for me. Was realizing you can see all this disgusting code that I wrote that's useless now. This file was like 100 lines of code, and now it's 1,000 lines of code at the end of the week, and it's all stuff that isn't being used anymore. And so I'm gonna have to go through this and delete all this. This was an idea I had, which was like, okay, we're just gonna check in our radius the height of the floors around us, and just see if I can do something this way. And it did not work at all. Anyway, so this is our collision. Let us get back to our update player. So this is what happens every frame, right? So we apply our velocity. This is just guaranteed if you're on the ground or off the ground, right? Oh, the reason why we have these frame drops, by the way, is because I'm tabbed out. So we have ground threshold and this. So this basically sticks us to the ground. So if we're at, we give like a really, really small amount of leeway for the player to be on the ground, because the reason why is because we don't want to be like bumping up and down and like it registering us on the ground and then off the ground and on the ground, off the ground. So we have like a really, really small threshold. Then, so here we are estimating the next z value of the player. So we're saying next frame, where do I think that the player is going to be at? The reason why we do this check after we apply velocity instead of before is because if I do it before, then you will occasionally get a frame where while like b hopping around, your velocity stops, right? Which I don't want. So I do this after, and then we determine where we're going based on proposed, because I have like these little bit of adjustments that I do based on if you hit the floor, we're gonna slow you down just a tiny bit, or if you hit the floor, we're gonna stop your z velocity, right? Just implied for all these 0, 1, 2s that you're gonna see is x, y, z, right? It's just vectors. So getting into the actual collision code here, I'm just making sure that I'm actually recording my code and not speaking over a blank screen. So our collision here, so this is how we deal with collision. It's x, y, and z in that order that we applied in. The reason why is because this returns a Boolean, and if this returns true, then I'm going to stop my x velocity, right? Otherwise, we're going to say, okay, this proposed vector was correct, and I'm going to shift my player there. So we do these separately because if you're moving in the x direction and you get stopped in the x direction, you don't want to get stopped in your y velocity. You get stopped, right? That allows you to kind of like skip along walls, right? So there's that. Now the complication comes with this when you're dealing with slopes. So let me switch over and give like a little bit of a visual for this. So let's say the player is moving up towards the slope, right? Now this is a surface, right? So how do we say, okay, you're good to go on this surface, right? How do we not get angry at the player for now putting in this frame his x into the surface based on the z, based on everything? Well, what we have to do is turn the surface into a floor that the player can walk on. So what we do is we sample the floor at that proposed x value. We take that x value and we say, okay, so what is the floor at this? Now this is going to get to be more complicated later when we have like real elevation and not just here's the floor and here's the ceiling. But for now, just for simplicity's sake, we just have that. So we take that proposed x and the original y, because we aren't doing anything with the proposed y yet, and then we just sample that. Now we go here, and here is where things get interesting, because now we are sampling the col tri-z, which is the collision triangle, which are the walls. This samples a vertical wall as a floor. What this function does is it clamps our x and y to the nearest and highest collision triangle perfectly vertical surface, right? It determines if this is higher than the floor, and if so, we are going to consider that the floor. So a lot of problems with that heuristic, but that is the simplest way to think about it for now. The reason why we have to, of course, clamp our x and y is because if you imagine this triangle right here, right, for example, you are never going to be exactly on the x value. Let's say that this is x equals 3 or whatever. You are never going to be on x equals 3. So what we have to do is we find this triangle, then we clamp our x and y to it, and then we figure out, hey, is this valid, right, in relation to all the geometry that is next to us. That's how the system works right now. So we sample basically the hypotenuse, or whatever the highest side of the triangle is. We sample whatever our interpolated z is at that position. Then we say if you were on the ground, or if you are on the ground, then we are going to say that that this floor is valid, because of course you don't want to be jumping over it and then like your z value gets popped over this surface. You know, you want to make sure that you're on the ground and getting this only applied when you're on the ground. So so then you take the floor change, right, the absolute value of the floor change. If it's less than or equal to the step height, then we take in this temp z, which is our original z, and then we change it by the floor change, right? So now we are saying for this z collision check, we are going to use this fake z that we just sampled from the floor. The reason why is because whatever the floor is, we don't want the player to collide with it, because we've accepted it as valid floor now. Then we do the collision check, and if we were doing a step up, then we apply these, and it basically accumulates into the z for the next one, right? And then we say our current floor is what we just calculated was the next floor that we just stepped up onto. And then we do the same check with the floor that we just calculated. We find the next floor, we find if it's we compare it to the last z value, which as you can see changed here, and then if it's higher we go up, right? And then we change the proposed, and then we do the z check at the end. So that's all of the basics of how floor is sampled and how we get around the collision checks. You can see I was really not having a fun time here. So, you know, there was a point where I was just printing out every single point of every single triangle. Because when we make these triangles on MapLoad, we make them with the assumption that they're actually quads. If I can show you what that looks like. So for example here, this has to be a square. So we're just gonna emit 2 triangles, right? But for this, we're emitting 1 triangle, and then the other triangle just becomes a point. right? Because these are actually 2 points. It's just flattened because there wasn't another. Do you see what I mean? So that took me a while to actually like figure out why some triangles were just bugging us out, was because I wasn't checking for those triangles, and they would come back with having invalid normals and mess up the calculations. So I eventually figured out why that was happening. But anyway, so there's that. So this is how we currently count up. So the idea is, right, when you have a wall, it's always going to be higher than your current z value. That's the assumption. So what we do is we find up here, we find our closest wall, right? We find our closest wall that's valid to sample. Then we come down here, and now we have to find the highest point on that wall. Well, to do that, we have to count up triangles, right, to the highest triangle. So what I do is I do this check to see, well, if our minimum and maximum values for our x and y are all the same for all these triangles, then they must be contiguous on one wall, right? So that's the logical assumption there. And so then we sample this triangle's height, and then we get the highest vertical sample, right? And I just have this here because these surfaces that we're testing right now are either going to be tagged slope face or wall. Okay, so then we check if we're less than the vertical sample, then we're going to block, or else we're going to continue. So that's how that works. That's how that works. Obviously, there's a lot of problems with this. Also, this isn't being used anymore. Okay, so let's talk about why this little bump happens and why there are bugs with it. So the issue with clamping player X and Y to a vertical surface is that the only way to detect valid surfaces at runtime is based on player radius. Here's why. Because when you fall off of a surface, you need exactly player radius on top of the surface to walk off, because that's the amount you're blocked when you get down here. So you need that much. So you need to be able to detect something that is right on the edge of player radius, right? This collision triangle right here. So that's why we need to search within player radius. This here will always find this as the higher floor. So naturally, we accept that as the higher floor, and we clip up to it. So now you might be thinking, oh, well, why not just accept floors that are within a certain little delta of our current z or our proposed z? So let's say we're moving up and our proposed z is like at 4.9, and then it sees a floor at 5, and then a floor to exactly sample at floor 4.9. Why don't we sample the floor at 4.9? Well, the issue with sampling the floor at 4.9 is because this issue, then actually we discovered that this isn't a sampling issue, this is a collision issue, because now we are colliding with this collision triangle because we are past the boundary here. So this is kind of the root of the bugs with this collision system, right? Is because we can determine when to start, right, based on which side is facing outward, but we can't determine when to stop collision if a player is on a contiguous collision triangle surface going up to it or down to it. Do you get what I mean? So this is the failing of the system. And you can try every type of heuristic with this. Like, I've tried calculating the difference in z between these different surfaces. I've tried calculating, okay, well, based on x and y, how much we clamp, we're just going to take the closest one. All of these ideas break something else somewhere else. Something will break. So we can't do that. We can't do that. So moving forward, what have we learned, and what in the future is going to be the attempt? Well, I don't really know. So I was thinking at map load, right? Since I generate all this stuff on map load anyway, at least for implementing it simply now, just in a test version, I could try to mathematically figure out contiguous surfaces, right? So if a triangle has the same min x or min y as this bordering triangle's max x or max y, right? Like, is there a way that I can link the logic between them so that when we are in these special cases, that I just ignore the collision of the next triangle before I reach that min value or whatever? If I can cache on this triangle the value to ignore this triangle, maybe something like that, that might be a possible way of solving this. It's like the only way that I can think of solving it at this point. The issue is that then this won't solve this issue, which is another really difficult issue. And so this whole thing, I might just have to put a pin in this until much later, because right now these aren't being interpolated as even triangles. They're being interpolated as just 4 points. So we don't even treat floor as triangles. So until later, like, I don't know, the structure, the data structure is going to have to accommodate for this edge case somewhere, you know. And in this bug, whatever this bug is, I have to figure this out. I'm assuming that somewhere it's emitting invisible surfaces, and that happens actually rarely. I'm kind of surprised that actually happened here. It's actually like a good kind of showing of all the bugs that are currently within the system that I need to work through. But yeah, so that's pretty much where the code is at, where the bugs are at. Oh, also, what I wanted to talk about, in the last video, I had stretched Z aspect ratio, which I didn't even notice, and I think it looked pretty cool, but I had to get rid of it for debugging purposes, just making sure everything looks as the world values do. So yeah, the Z value is stretched upwards, which I didn't even notice, but yeah, I was just, when I calculated my camera matrices, I was passing my screen resolution instead of my rendering resolution, so that's why that was happening. Some other cool stuff with the code. I did just open this, so we're going to be nowhere here. Some cool stuff that I really like, that I kind of wanted to show off, is like why I love C specifically, is right here. So I have this function called bitquad, right, that we do on runtime, right? Which does all the floor surfaces and the ceiling surfaces. I don't know why it lags so much when I try to record my code. Anyway, so what this does is it takes in this counter, and this counter is stored on every cell on vertex info, which is the floor start index. So this basically says for every single vertex, like this is where it starts. So when we need to edit it later, we have that values saved. So what I do here is I copy it by value and then I pass a fake pointer because I don't want to actually increase that. And what this ends up doing is reusing my code instead of having to make another function called like edit quad or whatever. I get to reuse my code completely, and it just dereferences a pointer to memory that's just going to be dropped at the end of the function, at the end of the scope, and never used again. It's not the most efficient way, but for projects like this where you want to reuse code and not like just copy code again and again and again and then have everything get confusing, that's like a really good thing to have. So that's why I love C. It's like thinking in pointers. I can't not think in pointers anymore. There's also the whole combo box thing is pretty funny because the combo boxes in nuclear require const char pointer, so you have to set up like a dummy array of chars that your const char points to, and that was annoying to figure out. Anyway, so next week I'm going to be working on lighting again, and the idea is like this. I've got this kind of like dream of like, oh yeah, did I show this off? It's like, this is kind of cool. This is what it looks like without the fog. I forget if I showed that off or not. But next week, the plan is to have more lighting stuff figured out. I kind of want like the light map to turn into like sampling a texture instead of just like a radial lookup table. I want it to like maybe pre-compute a texture that I got stuck here. That's not good. Yeah, the collision definitely needs weeks and weeks of work. But yeah, so I've got a dream about this lighting that's like, it's like pastel kind of painted on the walls sort of thing and like streaky, but it's gonna have to be something custom. Like that's the difficulty with these sorts of things. It's like I look at what other people have done and then I try it and it doesn't look how it looks in my head, sort of thing. So I have to figure out what I'm gonna do math-wise to distort this and blend it. Anyway, so I think that's pretty much the video of where everything is at right now. So I also have to add map saving and loading, like a menu. Like right now, map saving and loading works fine, but it's only one file, so I don't have like a naming thing or whatever. So movement is all the same. Everything else is all the same. It's just it was a lot of trying stuff out with the collision system to try and get it working, but yeah, I'm definitely gonna have to revisit it with a clearer head because I had a lot of burnout this week, and one day I just decided not to look at the code completely because I was really frustrated. So anyway, thanks for watching, and yeah, we'll see you.